Life Sciences, Lesson 29. Topic: Diversity, Popular Theories of Mass Extinction. Turn to Lessons 29 and 30 in the Learner's Workbook. These lessons include an individual activity and collection of evidence with formative and summative assessment. Integration. These lessons integrate with your studies of worldviews, ill health and disasters in life orientation. Prior knowledge. In grade 11, you learned about the impact of HIV/AIDS. These lessons will extend your knowledge of HIV/AIDS and other world disasters. Lesson overview. In these lessons you will learn about the causes of mass extinction. These include continental drift, ice age, heating and cooling of the atmosphere, extraterrestrial theories, meteor collisions, diseases.
Hi boys and girls, we're back again. Now we're going to be looking at diversity, but we're looking at popular theories of mass extinction. Where did all these organisms disappear throughout the years?
Hi, remember we left you with genetics, more with genetics. Now we're going to concentrate totally on population.
Okay, so we say, right, we got our popular theories of mass extinction. What happened? How did it happen? Each plant and animal species has something to contribute to life on Earth and originated from somewhere, clearly. I mean, they didn't just plop down and start. Extinction has occurred over vast scales over the ages, caused by shifts in the continental plates, the impact of meteorites, and also volcanic activity. And this is what the scientists have based it on. They've said the extinction is because of the continental plates, the impact of the meteorites having hit Earth, that's your Big Bang theory, and also the volcanic activity.
Now, the biological evolution, each time a few individuals of a species survive, adapts, and they diversify. Extinction occurs when the species is unable to adapt to environmental changes. So we look at fossil evidence proves that many of the organisms that lived long ago are now extinct.
Okay, so now we're going to look at what made them become extinct. What changed the environment to such an extent that they could not survive? And I think one that we all know about, that you do from nursery school onwards, are dinosaurs. And we've also got a couple of movies on dinosaurs that I'm sure all of you have seen anyway. But the dinosaur, where did they go to? Why did they disappear? And we're looking at the theories. Remember, the theories behind it. And these theories are based on scientific evidence. So we look at continental drift.
Now, all organisms are adapted to their biotic and abiotic environment. I think you remember that. Still, biotic are living and abiotic the non-living parts. If two habitats are the same organisms will be found there naturally. But this is not the case.
Now, that's what common sense tells us. You know, if you have an environment or two habitats that are the same, so let's say a place in South Africa and a place in Australia, and they are the same climate, we should have the same animals and species there. Hello, we don't have any kangaroos. You know, so
Yes.
do you follow what I'm saying, people? You've got to remember, common sense would say, same here, same there. Even though they're different continents, they should be the same organisms. They are not. We have different species. And when we bring an alien species from another country to our country or to our habitat, they become alien species. And they then become a problem because they don't have natural predators, they don't have natural enemies. Remember that anything that is naturally found in an area is indigenous. It's just relating back to environment, so that all our sections link together in the syllabus. All right, so if the two habitats are the same organism will be found there naturally. No, this is not the case. Plants and animal species are discontinuously distributed across the world. You must know that term, discontinuously distributed, so they are not continuous.
Discontinuous distribution is based on the concept of organisms originating in an area and then dispersing outwards. So many species are then found living naturally in areas that are very far away from each other. Fossil evidence shows that distribution of species was not always as we know it today.
Okay, and that our paleontologists and our archaeologists have researched and found and checked. So they've come up with the fossil evidence. 1912, we had a chap called Alfred Wegener, and he proposed that all the different continents seemed to fit into one big puzzle. We were all just one big landmass. He proclaimed that all the continents were once one huge piece of land, and this he called Pangaea. And we've got a picture for you, which will come up on a slide just now. Plants and animals would have competed with one another, and this would have led to extinction. We also had marine life. That would also be greatly affected, because remember, if everything was one big land mass, it would also affect the shorter coastlines. This supercontinent broke up into pieces approximately 180 million years ago in a process called the continental drift. Wegener could not prove his theory, as he could not explain what would have caused the continental drift. But that will explain why, if we look at some areas, we have similar plant and animal life to areas on a completely different continent. It's similar, it's not the same. They've changed though. Okay, so by 1960, scientists were able to explain the theory of continental drift, so they helped old Wegener do his thing.
Okay, so let's look at this theory now. The Earth's crust is composed of 7 large plates which float on the layer of the Earth's mantle. The land masses are located on top of these plates that move by plate tectonics, cause the land masses to now move. The areas where 2 plates meet is characterized by much geological activity, and this causes the formation of mountains, earthquakes, and volcanoes. Now, the Himalayas were formed when India's plate crashed into Asia's plate. So when the 2 plates move away from one another, the area in between gets larger, like land masses situated opposite each other in the Atlantic Ocean. What happens now? Lava builds up between the plates, preventing the plate from moving back.
It's actually, you know, it almost sounds like you take this puzzle, you break it, and where they bash into each other in other places, it sort of crumples the paper, if you can imagine that happening to a puzzle. And this is what Wegener thought but could not prove. And then the scientists in 1960 came along, and they were actually able to, or they came up with explanations for it. Something else, remember the center of the Earth is a molten rock. It's just, it's incredibly hot. And you've got this, it's almost like lava in a volcano, and it's floating around and doing its thing. And on top of that, you've got your plates, and those plates move, and the land masses sit on top of the plates. So that's how you have the crashes and that also explains our earthquake belts.
Yes.
You know, you've got areas where people are they're prone to earthquakes.
Yeah.
Learning Channel offers an extensive educational collection ranging from grades 8 to 12 in alignment with the National Curriculum Statement. We offer DVD and workbook sets in a number of different subjects. To buy the Learning Channel series, check out our website on www.learn.co.za or call us on 011 639 0179.